Here we will be discussing rational, which are fractions, as exponents. So rational exponents, this is the main rule for when you have an exponent that is a fraction. So if you have x to the m over n, can be rewritten as a root, and you're taking the nth root of x and then raised to the m power, or you can first take x to the m power and then take the square root. This is far more common to use here, first taking the root. All right, let's take a look at these three problems here. They all look pretty similar. So let's see what 25 to the 1/2 power really means using our rule. So we see that the n here, the denominator of our rational exponent, is 2. That means we're going to be taking a square root. In math, we don't normally write a little 2 here. We just assume that it's a square root if it's 2, so you don't need to write the 2. And our m value here is 1, so we'll be raising it to the first power. So this can be rewritten as the square root, so I'll put the 2 there. Again, don't need it, to the first. All right, well, what is the square root of 25? It's 5, and what's 5 to the first? It's just 5. So raising something to the 1/2 power means taking a square root. Take a look at the one in pink here. This negative out front is literally out front. We're not taking negative 25 to the 1/2. In fact, this is really 25 to the 1/2 first, and then you multiply it by -1. So remember, think of PEMDAS here. All right, so we're going to take 25 to the 1/2 power. We know what that is, so the negative is just going to stay out front. Again, it's a square root and it's to the first, so this answer is, we know that this part is 5, and then there's a negative out in front. So our answer is -5. Let's take a look at the one in green. Now the parentheses are around the entire -25. That means I'm taking the square root of -25 and then raising it to the first. The parentheses tell us, hey, this entire thing is to the 1/2 power, whereas here the negative was out front with no parentheses around it. It was just the 25 to the 1/2, and the negative times -1 out front came at the end. Here we want to take the square root of -25. We actually can't do that because we cannot take the even root of a negative number, so this does not have an answer. There's no number that when multiplied by itself gives us -25. Here we have two more examples. We're using 25 again. What this means is we're still taking the square root because the index or denominator is 2. I'm not going to write a 2 there though because we know that we don't need to. And then we're going to raise that to the third power. Now our m, or our numerator, is not 1 anymore, it's a 3. So we're going to first take the square root of 25. Like I said, normally you want to take the square root first. And then we're going to be raising that to the third power, and 5 cubed is 125. And then 243 over here, we want to rewrite this. We're taking it to the 2/5 power. So 5 is our index. It's the type of root we're taking. We're taking a 5th root. We do need to write the 5 there because it's not a square root. And then we're raising it to the 2nd power. The 5th root of 243 is 3. And then we're going to square that, so our final value is 9. Now, please note that when we take something to a power greater than 1, like 3 over 2 is greater than 1, we're going to end up with a value that's greater than our original base. When we take a number to an exponent that is less than 1, such as 2/5, we'll end up with a number that is less than our original base. Okay, let's take a look at these last two. They almost look exactly the same. Taking 8 to the 4/3. 4/3 is greater than 1, so I know my answer is going to have to be greater than 8 at the end. We're taking the cube root of 8 and then raising it to the 4th power. The cube root of 8 is 2, and 2 to the 4th power is 16. Over here, we want to take the cube root again, but this time of -8, and then raise that to the 4th. When we're taking an odd root, we can take it of a negative, because there is a number out there that when multiplied by itself 3 times will give us a -8, and that number is -2. Then we're taking -2 and raising that to the 4th power. Raising any value to an even power will give you a positive number. So in this case, they ended up being the same. It won't always be that way, but you do have to be careful with the negatives with rational exponents.